Hello students, this video is about Cpctc, corresponding parts of congruent triangles. So the goal of this lesson is to be able to use this theorem to prove that parts of triangles are congruent. So first of all, what does this stand for? Well, Cpctc is an abbreviation for the phrase corresponding parts of congruent triangles are congruent. And this can be used as a justification in a proof after you have proven that two triangles are congruent. So let's say that we have two triangles and we know that they're congruent. Well, once the two triangles are congruent, then we can say that any part of them we want is congruent. So if I have these two triangles and the question is asking you, okay, are these two random angles congruent? Well, the answer can be yes if you know that the yellow triangle is, if the entire yellow triangle is congruent to the entire green triangle, then yes, those two angles would be congruent because corresponding parts of congruent triangles are in fact congruent. So here's an example of that. Let's say that A and B are on the edges of a ravine and the question asks you to find the length of AB. How long is AB? Well, when I look in this picture, I can see that it looks like AB should be 18 because this other side is 18, right? Well, in order for me to know for sure that it's 18, I would have to know that this whole triangle is in fact congruent to the triangle on the other side. So we need to study the information in the picture, decide whether or not those two triangles are congruent, and then if they are, we can match up the sides and say that AB is the same as this 18 over here. So the first thing we notice in the picture is that one angle pair is congruent. In the middle here, in the middle right here we have a vertical angle, so the angle on this side would be congruent to the angle on this side. Those are vertical angles. And then the side that's 10 is equal to the side that's 10, we have that side equal, and then the side that's 15 is equal to the side that's also 15 on that other triangle. So we have equal a side and then this angle and the other side. So actually the two triangles are congruent by side, angle, side. So now that we've said the two triangles are congruent, now we can say that AB must equal 18, but AB must equal 18 just like this side does. Why? It equals 18 by Cpctc. All right, another example. Let's say that they want us to prove that angle XYW, so XYW would be this angle at the top, is congruent to angle ZYW, this angle on the other side, the top. Okay, well, in order for those two angles to be congruent, what we would have to know is that the triangle on the left is congruent to the triangle on the right. If the two triangles are congruent, then we can say that the two angles would be congruent. So let's walk through this proof. The first thing that they did was they told us that YW bisects XZ. So that's given. What does it mean for it to bisect? Well, bisect means to split it into two equal pieces. So if YZ is bisecting XZ, then XZ has been split into two equal pieces. This piece on this side, XW, must be equal to the piece on the other side, WZ. So XY is equal XW is congruent to WZ by the definition of angle bisector. So the next thing that they told us in the given was that XY is congruent to YZ. Okay, so the pieces on the outside are congruent, that was given. And then we also know that these two triangles share a side, they share YW. And so YW on one triangle is congruent to YW on the other triangle, and that is the reflexive property of congruence. So we have now said that this side was congruent by bisector, this side was congruent by given, and the side in the middle is reflexive, so that's all three sides. These triangles are congruent because of side, side, side. Triangle MNO is congruent to triangle OPM by side, side, side. So now that we know the two triangles are congruent, we can reach our conclusion and state that angle NMO is congruent to angle POM by corresponding parts of congruent triangles are congruent. Cpctc. Okay, so let's try another proof. Okay, this proof is interesting because it brings back some of our other geometry skills with parallel lines. They're given that NO is parallel to MP and that angle N is congruent to angle P, prove that MN is parallel to OP. So, a helpful hint, when you're doing these proofs, you should work backwards to plan the proof. To show that MN is parallel to OP, look for a pair of angles that are congruent. So they're telling us that these two sides here are supposed to be parallel in green. Well, if those two would be parallel, what angles would be equal for them to be parallel? Well, the angles that would be equal are called alternate interior angles. Okay, this line from M to O is a transversal that cuts through the parallel lines, and when this transversal cuts through, it makes the two angles on the inside here, angle NMO and angle POM, equal. So the alternate interior angles are what we are looking at here as far as wanting them to be equal. If we can say that those two angles that I've marked in green are equal, then it would be true that those two lines would be parallel. So, okay, so that's what we want to prove. Now, in the given statement, they told us that lines NO is parallel to MP. So if those two lines are parallel, can we apply alternate angles again? And which angles would be equal now? Well, this is the line from O to M that cuts the red lines. Okay, so the alternate interior angles would be here on the inside OMP and angle NOM. Okay, those would be our alternate interior angles that would be equal. So, what we just said was that angle N is equal to angle P and that those two lines are parallel. That was given. And then once those two lines were parallel, the angle on the inside here, angles NOM, is parallel to angle, is congruent to angle PMO because they're alternate interior angles. So, we also know that these two triangles share the side of MO. So MO is congruent to itself via the reflexive property. So now we can say the two triangles are congruent to each other because we have this side, we have the angle MON, and then we also have the angle N up here. So we have angle, angle, side. And if you are drawing a picture, you should go ahead and mark those so you can see the physical markings. Mark that side, mark this angle, mark angle N. Okay, so the triangles are congruent by angle, angle, side. So now that the triangles are congruent, we can say whichever pieces we want to be equal. So now what we were interested in was angle, remember on the previous slide, we were interested in angle, what was it, over here, NMO on this side to be equal to POM, because if those two angles are equal, that makes the lines parallel. So we're going to say that those two angles are equal. Why? Because they're corresponding parts of congruent triangles, therefore congruent. And now that those two angles are congruent, we can say that yes, the lines are in fact parallel by the converse of the alternate interior angles theorem. So because the alternate angles were equal, Now the lines are parallel. Okay, and the last kind of proof we have is one on the coordinate plane. So here I have some points D, E, F and some more points G, H, I, and they're asking us to prove that these two angles are congruent. Well, the first step is to plot the points on a coordinate plane. So if I were to draw all these points, I get two triangles like this. Now, if I want to say that these two angles are congruent, what I really need to know is whether or not these two triangles are congruent. Because if the triangles are congruent, then I can say whatever I want about I can say the angles are congruent. So I need to prove the triangles are congruent. Well, the easiest bit to prove with these triangles being congruent would be, I don't know, what do you think? Is it side, 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 angle, angle, side, angle? Well, I can use my distance formula to find the lengths of the sides. If I use my distance formula and find the length of EF, it should be the same as HI. And then a distance formula again for GH, it should be the same as DE. So I'm going to use the distance formula to find all three sides of one triangle and see if they're equal to all three sides of the other triangle. So do you remember the distance formula? This is the one with the big square root. We're going to have to do the distance formula 6 times. 3 sides for one triangle and 3 sides for the other. Boom. Okay, so here's the distance formula at the top. And here I have plugged into the distance formula 6 times. And for DE, I got 2 square root of 5. Well, for GH, I also got 2 square root of 5. And for EF, I got square root of 5. For HI, I also got square root of 5. For DF, I got square root of 13. And for GI, I also got square root of 13. So some of the sides from this triangle are actually equal to the sides from the other triangle. So since all 3 sides are equal to each other, therefore, triangle DEF is congruent to triangle GHI by side, side, side. And now that we know the triangles are congruent by side, 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 we can reach the conclusion that the angles are in fact congruent by corresponding parts of congruent triangles are congruent. Good. So, hopefully now you know what Cpct stands for. It stands for corresponding parts of congruent triangles are congruent. Hopefully you know that you can use this to decide if parts of triangles are congruent after those triangles are in fact congruent. And we can use this to write proofs, usually at the end of the proof, after we've shown the triangles to be congruent. And this lesson also happened to review what alternate interior angles are and the distance formula. So good job!